So in our previous class, we talked about atmospheric pressure. I introduced you to what atmospheric pressure is. Okay, and remember that atmospheric pressure is the pressure that we feel because of the weight of the air. Okay, because of the weight of the air that is all around us. So when there is air, okay, around us, there's going to be atmospheric pressure. Okay, and then we talked about the values of atmospheric pressure. Can somebody please tell me what is, there are three values of atmospheric pressure that I've given to you all. Usually we call this PATM lah, okay, referring to atmospheric pressure. Can somebody give me the first one, please?
1.03 times 10 to the power 5 Pascal.
Okay, Pascal, otherwise also known as Newton per meter squared lah. Okay, mana-mana satu pun boleh. Okay, the second one, somebody else?
76
Okay, 76 what? Unit?
mm. Millimeter.
76 mm is not correct.
cm.
Cm what?
hg.
Okay, cmHg, because Hg is the chemical symbol for what?
Mercury.
Okay, for mercury. Okay, very good. The third one, okay, 10 meters water. Okay, the third one is 10 meters water. Okay, and we have also learned, okay, two instruments. Okay, two instruments that are used to measure, okay, to measure atmospheric pressure. What are the two instruments?
14 barometer.
Okay,
Aneroid barometer.
Okay, 14 barometer and aneroid barometer. What is the biggest difference between these two barometers?
14 barometer have liquid.
Okay, 14 barometer have liquid. What is the liquid inside a 14 barometer? Usually.
Mercury.
Okay, it's mercury. Whereas aneroid barometer, the word aneroid, okay, kind of the same meaning. If you remember your biology is anaerobic. Okay, so aneroid actually refers, the word aneroid means without liquid. Okay, so it's a barometer. It measures atmospheric pressure, but just without any liquids. Okay, they use a different system altogether lah. Okay, then we talked about the differences between the 14 and the aneroid. When is a suitable time to use 14 and when is a suitable time to use aneroid. So today our main work is to work on the calculation problems. Okay, I think that I will have to have another class after this lah, because this subtopic is very big pula kan. So today we're going to just talk about calculation problems. Okay, and then tomorrow we'll talk about the application lah. Okay, so today is this, as you can see all over here, these are the different units for pressure. Okay, the only one that we are familiar with is Pascal over here, centimeter mercury over here. I don't really see meter water there, and meter water. Okay, it can also be centimeter water over here. It can also be inches water over here, depending on, you know, what is the measurement that you want to use. It can also be millimeter water, also can. Another common one that we always see is this PSI. Kalau especially, let's say you pump air into tires. Let's say you go to a petrol or Shell station, you pump air into tires, the meter over there shows PSI. Okay, PSI is kind of like an old pressure unit. Okay, I think it's per square inch. I can't remember what is this one. Okay, but I know it's square inch lah. It's also another unit for pressure. Okay, so our main job today, okay, is to know how to change between the various units of pressure. So far for you all, okay, as you have mentioned, we have three lah. One is Pascal, one is centimeter mercury, and then the third one is meter water. So how do I want to change? How does this 76 centimeter Hg become 1.03 times 10 to the power of 5 Pascal? Okay, and that's the thing that we want to learn today. Okay, so the unit for pressure, SI unit is always the same lah. Okay, it's always Pascal. Okay, but in certain fields, we use different units, and the four most commonly used ones are Pascal, millimeter mercury, or centimeter mercury, meter water, and this last one is called millibar. Okay, and the short form for millibar we call mbar lah. It's not mbar, okay, it's mbar. Okay, jangan juga kamu 20 mbar. Okay, that everybody says, what's this mbar? It's mbar. Okay, 20 mbar, for example lah. So there are 4 units that you need to know: Pascal, millimeter, mercury, meter water, and millibar. Okay, or mbar lah. So let's take a look at the four units now. So Pascal is the SI unit for pressure, and usually in science, okay, we use Pascal because that's the SI unit. Okay, so values of pressure need to be converted to the unit Pascal before substitution in physics formula. So this is a very important thing. Whatever unit you use, okay, you need to convert it into pressure. You need to convert it into Pascal, okay, before you can use it in your calculation. Okay, so for example, the atmospheric pressure at the peak of Mount Kinabalu is about 60,000 pascals. Okay, which makes a lot of sense lah. At sea level, is 103,500 pascals. So you see the amount of difference of the atmospheric pressure at sea level where we are in Kota Kinabalu. Okay, and in Mount Kinabalu, pada puncak Gunung Kinabalu is 60,000 pascals. There's 40,000 pascals of atmospheric pressure is lost because of the altitude. Okay, remember that in our previous class, I said that the higher the altitude, the bigger the altitude, the lower the atmospheric pressure. Okay, so this is a very important thing. Okay, now millimeter mercury or centimeter mercury is what we call a manometric unit of pressure. Okay, it uses the metric system. So we usually use this in, say for example, medicine, in meteorology. Meteorology is kaji cuaca. Okay, aviation is Elijah's field lah. Okay, yang kapal terbang. Sometimes we also use it in science. Okay, so for example, this blood pressure yang kita selalu design is 120/80, right? Okay, remember if you have seen the what is that thing that is used to take blood pressure, the one that you have to picit, then lepas tu dia dia kasi lepaskan. Okay, so that 120 and that 80 actually refers to this millimeter Hg. So it's 120 millimeter Hg and 80 millimeter Hg, millimeter mercury. Okay, so that's kind of the blood pressure. Okay, the high and the low. Okay, and then of course 120 and 80 is normal blood pressure. Your blood pressure should fall between 120 to 80. Okay, I think you already know. I'm not sure whether you already know. 120 refers to what, and then 80 refers to what. Do you know? You know? Okay, never mind. Try and check it out. Okay, meter water is a metric unit. Okay, and we usually use that now for places like the sea, water in the sea, where there's a lot of water. Okay, in reservoirs and in dams. Okay, di empangan biasanya kita akan gunakan meter water because the level of water is high lah. Okay, and usually we usually talk about meter water for atmospheric pressure because of the liquid inside. Okay, so we use the same unit now. So for example, the water pressure in the Bakun Dam, okay, is about 150 meters water. That's pretty high lah. Okay. Now, millibar is a very small metric unit. Okay, dia ada unit yang sangat kecil. Okay, so we use it on a micro scale lah. Okay, and we usually use it in the field of meteorology. Okay, meteorology is kaji cuaca. Okay, so kaji cuaca we use millibar. Okay, and it's equivalent to the unit hectopascal. Okay, HPA. Does anybody remember? Hecto is 10 to the power of what? Don't even remember myself. Yeah, go and check lah. Hecto is 10 to the power of, I think it's negative something lah, but I can't remember. Negative. Hecto. Maybe negative 7 macam. Yeah, I'm not sure. Okay, I'll check this out lah. Okay, 1 millibar is about 1 hectopascal. Okay, so the conversion between millibar and pascal is pretty easy lah. Okay, the atmospheric pressure is about 1013 millibar. Okay, all right. Sorry. Okay, sorry. So the first thing we need to do is this is example 1 in your textbook now. The first thing that I want to teach you all is how to change, for example, centimeter Hg or millimeter mercury to Pascal. Okay, this is the important thing lah. Okay, and we use the formula that we learned in the previous subtopic, which is liquid pressure equals to rho Hg. Okay, so except that now, since we are using mercury, if it is millimeter mercury, then this density will be the density of mercury. Okay, which is given over here, 1.36 times 10 to the power of 4. Okay, H refers to the height at the certain pressure. Okay, so for example, 76, if it's 76, this one, if it's 76 centimeters and 76 centimeters lah. In this case, is 160 millimeters. The only thing you have to remember is the H must be in meters. So you have to convert the H to meters before you can calculate the whole thing. Okay, and then G is our very good friend since the beginning lah, 9.81. Okay, so can you please convert? No, it's actually no point to convert lah, because you already know this is in your textbook, right? Okay, so this will be P equals to 1.36 times 10 to the power of 4. Okay, that's the density of mercury. The only problem is now my H. My H has to be 160 millimeters convert into meters. Okay, so as you can see over here, 160 millimeters is about 0.16 meters. Okay, so you put the 0.16 over here, 1.36, 9.81, and you get this. Okay, 2.13 to the power times 10 to the power of 4 pascals. Okay, now what I want you all to do is to convert our atmospheric pressure. Okay, from 76 centimeter mercury, use the same value, the density of mercury is this. Okay, I want you to convert it into Pascal. How much is it exactly after you use 76 centimeter Hg? Can you count 76 centimeter Hg and also 75 centimeter Hg? Okay, because we know that actually this one in Pascal is 1013000. Okay, is it 1013? Or 103500? Sorry, 103500. 103500 Pascal. Okay, I just want you to double check for me, 76 or 75, which is closer to this value. Okay, can you check it now, please? Okay, anybody got 76 centimeter mercury? How much?
76, 101, 396. 396.16.
Okay, how about 75?
7.
Yeah, somebody else? Yeah?
100,000 and 62.
100062.
Yeah.
Oh yeah lah, 1035 is wrong, 1013 pula. Okay, 100,062 pascals. Okay, so the reason why I asked for 75 is because there are certain books okay, there are certain books that put atmospheric pressure as 75 centimeter mercury for some strange reason or another I also don't understand. Okay, but actually the actual one is 76 because if you look 76 is actually closer to the actual value of atmospheric pressure. Okay, I think soon we will see a few questions that kenapa dia orang pakai 75. Okay, but I want you to know that if the book use 75 or if the question use 75, use 75. Okay, don't go and use other things. Okay, but generally if you're not given the value, you should know that it should be 76 centimeter mercury, and then when you convert it, it becomes 101,000 beginilah. Okay, lebih kurang lah. So this, but usually we write it as 1.013 times 10 to the power of 5. Okay, pascals. This is kind of the standard value, 1.013 times 10 to the power of 5 pascals. Okay. Now, let's take a look at this situation. So in this situation, you have this air that is trapped over here. Okay, so this side over here is all air. over here is all air, over here is all air. But each case is different. Okay, pay attention to this. So you have to calculate the pressure of the trapped air in each case. Okay, so given the atmospheric pressure is 76 centimeter mercury, of course you use 76 centimeter mercury, or you can also use 760 millimeter mercury. Now, I want you to pay close attention. This is case number 1, this is case number 2, and this is case number 3, because all 3 cases are slightly different. Okay. Now, in case number 1, what we find is that the air is pushing upwards. Yalah, because the air wants to mau melepaskan diri bahkan. Okay. But since the mercury over here, okay, is being acted on by gravity, it's going to go to the downwards direction. Okay, so this 15 centimeters of mercury is going to put on a little bit of pressure on the air. And then of course, because this is terbuka bahkan, disebabkan ini adalah terbuka, so there's going to be this atmospheric pressure. So in this case, we say that the air pressure is equals to the atmospheric pressure plus the pressure because of the mercury. This is liquid pressure, people. Okay, this is liquid pressure. Sebab the 15 centimeters puts on the pressure on the liquid. The 15 centimeters of mercury, okay, mengenakan tekanan. Okay, so the arrows actually help us to determine how to form the equation. Since this is balance, maksudnya ini mercury ni kan dia berhenti bergerak sudah bang. Kalau dia masih bergerak kan means there is no balance in pressure lah. But since the 15 centimeters of mercury is no longer moving, so we say that you can say that this is like a balance force situation lah. But in this case, it's balance pressure. The atmospheric pressure plus the pressure from the mercury, okay, is equals to the gas pressure, okay, or the air pressure from the air inside here. Okay, and so we can count. We can actually count the pressure of trapped air because we have atmospheric pressure, which is 76, and then the mercury pressure is 15. And the good thing is we don't have to use P equals to H rho G. We just have to use centimeter Hg saja. So 15 centimeters of mercury will obviously kenakan 15 centimeter Hg lah. Kan? So all we have to do is just plus together and we get 91 centimeter Hg or 910 centimeter mercury. Okay, so knowing how the equation is formed is very important. Okay, but as I said, case number 1, case number 2, and case number 3 are 3 different cases. Okay, case number 1 is the atmospheric pressure plus the mercury is equals to the air. But now, case number 2, this is the important thing. Where is this mercury going to go? Is it going to go up or is it going to go down? Okay, the obvious answer is it's going to go down because, you know, you put it this way, kan? Obviously it's going to go down. It always goes down. Even in this case also, it's going to go down. Okay, so what's going to happen here is you have the air trap that's obviously wanting to get out. Dia mau melepaskan diri. So dia memang akan ke bawah. Okay, but now you have a different situation. The mercury is going down, but the atmospheric pressure is going up. Okay, can you form the equation for me, please? Somebody? Take a look at the arrows and tell me how to form this equation now.
PATM equals to PA plus PHG.
Okay, PATM equals to PA plus PHG because of the arrows. Okay, so we know PATM. PATM is 76. We know what is PHG. PHG is 15. And we can easily count the pressure of air. Okay, so 76 minus 15, you get 61 centimeter Hg equals to 610. This is totally nothing calculation lah, no complicated formula, nothing. It's just pakai logic saja. Okay. Now, case number 3. Once again, where is the mercury going to go? Is it going to go to the left or is it going to go to the right?
I think right.
It's going down.
Some people say right, some people say down. Okay. But I asked you a question, is it going to go to the left or is it going to go to the right? I didn't say anything about up or down. Because look at how is the mercury going to go down, right? It's going to go left or right only, ma. Because it can either fight against the air or it can go out of the hole over here, lah.
Left, left, left.
Oh, so you say the
Stationary.
mercury is... okay, the mercury is stationary. Oh, okay, that's interesting. So I can't remember who said it just now. Somebody said the mercury is going to go down, which is like, how's it going to go down? Because there's like the other ruang. Okay. Okay, so the moment that you've all been waiting for, okay, the moment where Mr. Marcus gives the answer. Okay, actually, mercury doesn't change anything right now. Mercury always goes towards the earth. So actually, whoever that answered that just now was correct. Mercury is always going to go down because it follows gravity. Okay, and because Mercury is going down in this case, it is not involved in the fight between air and atmosphere. Dia tidak terlibat. Okay, so dia tidak membantu pun. It's going in a different direction than the direction of the air and the direction of the atmosphere. Where is the direction of the air? This air over here is going to fight to go which direction, left or right?
Right.
Right.
Okay, it's going to go to the right. Sebab dia mau melepaskan diri. Okay, air is like, 27 students in a physics class. Okay, they just can't wait to get out of the class. So it's like, okay, that's all for today. Thank you, sir. Thank you, sir. Thank you, sir. And call, begitu kan? Macam tu lah kamu. Okay, so the air trap is always wanting to get out. So it's going to go to the right. Atmospheric pressure, since this is the hole, atmospheric pressure is always going to go to the left. And since our friend Mercury is stuck in the middle, okay, so the Mercury actually totally no contribution to this matter. So in this case, we say that the air pressure is equals to the atmospheric pressure. Take a look at case 1, case 2, and case 3. Three different cases, okay, that require you to think logically how to form the equation. Don't memorize this, okay? Just think logically. Where is the mercury going? If the mercury is going down, then follow the direction of the mercury. Okay, form the equation. Don't memorize this thing because it's not worth memorizing. Okay, it's very easy to think about it logically. Okay, so in case number 3, atmospheric pressure is equals to the air pressure. Okay, so the air pressure will be 76 centimeter mercury, which is 760 millimeter Hg. Okay. All right. Second type of question is this. Diagram shows an apparatus setup which is used to measure atmospheric pressure. Okay. Calculate the pressure at point Q in unit centimeter Hg, millimeter Hg, and Pascal. Okay. Let's think about this first. So over here is 10 centimeters of vacuum, and then over here is 75 centimeters. Okay. What is this thing called again?
14 barometer.
Okay, 14 barometer. One person answered, then the rest also answered at the same time. So interesting. Okay, so it's a 14 barometer. Actually, this is a simple 14 barometer. The real 14 barometer is like a little bit more complicated. Okay, so in order for you to calculate the pressure at this point, we need to consider two things. Number one, there is always atmospheric pressure. Okay, and then number two, orang yang berada pada titik Q ini is not only feeling the atmospheric pressure, but it is also feeling the liquid pressure. Okay, so the total pressure will be the atmospheric pressure, which very interestingly, dia guna 75. I also don't know why. Okay, 75 plus the liquid pressure of 15. Okay, and then you'll get 90 centimeter mercury. And then only you convert it to Pascal. Okay, so 1.36 times 10 to the power of 4, G is 9.81, H is 0.9 because change millimeter Hg to meters. Okay, so you get 0.9. And then you will get the value of the pressure in Pascal. Okay, can you change the 75 to Pascal, 15 to Pascal? Also can lah. Okay, but it's like a lot of work lah. Okay, so sometimes it's easier to calculate the centimeter mercury first. Kasih jumlah dulu the centimeter mercury. And it's very easy because it's just plus only. No complicated times this, times that. Okay, just plus the atmospheric pressure, this one, and the 15. Okay, the only thing that I want to mention is Kenapa dia 75? And then why do they give this 10 centimeters? For what 10 centimeters? Okay. So the 10 centimeters actually sebenarnya dia tiada guna ini. Because this height because this height is the atmospheric pressure dengan syarat this thing is a vacuum. Very important. Okay, if the column of trapped air over here is a vacuum, tiada udara di sana, then you know that whatever this height is the atmospheric pressure. Okay, that's a very important thing, because in the next example, you see that now this space over here, there is a gas. And when there is a gas, there is going to be this over here. Okay, so my question is, how much is the pressure of the gas? If the atmospheric pressure is 75 centimeter Hg. Okay, guys, this is the exact same problem, exact same problem as the one just now lah. Except that now you're inside this mercury, but it's still the same thing. Atmospheric pressure is going to push here. Okay, this 40 centimeters of mercury is pushing in what direction?
Down.
Okay, it's going to push down. This situation and this situation, the one that we saw just now, okay, so let's say this is 40 centimeters lah. Okay, this is the air, the pressure of air is pushing downwards. This 40 centimeters of mercury is also going to push downwards against the atmospheric pressure, 75 centimeters of the sun. Can you form the equation based on this situation?
PATM equal to P air plus PHG.
PHG. Okay, so since the PATM is 75, the P air is 40, so you can get the the P air is, I don't know. Okay, the PHG is 40 lah. Okay, so you can get the value of the pressure of the air, which is 35 centimeter mercury. And then you change it to Pascal if you want lah, but actually you don't have to, because they tidak minta pun apa-apa unit. So if they say calculate the pressure exerted by gas X, if you leave your final answer as this, it's also already correct. Because centimeter mercury is a unit of pressure. Okay, don't need to sibuk-sibuk change to Pascal if you don't ask for it lah. Okay, fourth question. Maximum pressure that a wall at the seaside can withstand is 3.6 times 10 to the power of 5 Pascal. What is this maximum pressure in meter water? Okay, so same thing. If you want to convert from Pascal to meter water, okay, you need to use P equals to rho GH. Okay, find the value of H, and that is the pressure in this one. So after you get the value of H equals to blah 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 meter, then you have to change lah. So the pressure equals to blah 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 meter water. Okay, can you calculate this for me, please? Pressure given, pressure is 3.6 times 10 to the power of 5. Okay, the rho is given over here, the G is given. Calculate the H for me, please. Okay, calculate it, please.
36.70
36.70 70 what? Meters. Can somebody verify this, please? Is this correct?
Yes.
Okay. So if it's 36.70 meters, if the depth of the water is 36.70 meters, so the pressure will be the same, 36.70 meter water. So you see the conversion from height to pressure if it's meter water is very easy. Just take the height law and then just add the correct unit to call it pressure. So it's very, very, very convenient. You don't have to change to Pascal all the time because Pascal actually is scientific, but it's very, very mafan. Okay, let's try another one. Actual pressure at the depth of 125 in a dam. Okay, state your answer in meter water and then convert it to Pascal. Okay, remember at the depth of 125 meters, so this is 125 meters. This fish is going to experience two pressures. First pressure is obviously atmospheric pressure. Okay, and it's also going to experience the liquid pressure. Okay, so you imagine at the surface of the water, you only experience atmospheric pressure. But actually, when you go deeper and deeper, you not only still experience atmospheric pressure, you also experience the liquid pressure. Okay, can you find the actual pressure, please? State your answer in meter water first for me. How much is it? It will be 10.3 plus, because atmospheric pressure is 10.3, right? And since we're using water, let's use water lah, plus 125 meters of water. Okay, poor fish, no wonder dia berkempis. Okay, so 10.3 plus 125 is 135.3 meter water. Let me see. 135.3 meter water. Okay, convert this into Pascal, please.
One
Sorry?
million. Yes. 1,300,000 and 293.
Wow, exactly. There's not even a point. Tiada point kah? Memang tepat-tepat.
Yeah.
1327293. Okay. Pascal. Let's check lah. Okay, over here. You're cheating lah, I tell you. Okay, kalau 1327293 is correct, except that you should convert it into standard form lah. Okay, 1.33 times 10 to the power of 6 Pascal. That's a lot of pressure. Okay, 1.3 times 10 to the power of 6. 1 million, you know, guys. Okay, million is like, wow, no joke. Okay, so yeah. All right, let's do a couple of questions over here. So the first one is, diagram below shows a manometer used to determine pressure in a gas tank. Which comparison is correct about pressure in a gas tank with the atmospheric pressure? Who is winning in this case?
C.
C. Pressure in the gas tank is less than the atmospheric pressure. Can whoever explain this, explain why? Why do you think the pressure in the gas tank is less than the atmospheric pressure? Sorry, I don't know who
Because
answered that just now.
length of manometer of atmospheric pressure is less than the gas.
Okay, I think that's a very acceptable explanation. If you look at the level of the, actually this is mercury lah. Manometer is the whole tube. Okay, this is mercury. If you take a look at the mercury levels, kita nampak yang the one that is nearer to the gas is higher, the one that is nearer to the atmospheric pressure is lower. So this means that the atmospheric pressure is stronger than the gas pressure. Okay, so dia macam tarik tali lah, bahkan. This is really like tarik tali, but it's a tarik tali between gas and atmospheric pressure. And in this case, it's very obvious that the gas is winning. The gas is winning. Sorry, not really tarik tali lah. Sorry, tolak tali. Tolak lah. Okay, obviously atmospheric pressure is winning because it is able to push more than the gas. Okay, so C is the correct answer. Next, figure shows a simple mercury barometer. Which one shows the height to measure atmospheric pressure? My gosh. Sorry, what's the answer?
D.
D. Oh, okay. Really, D. Nope, D is not the answer.
A.
A. From the surface over here all the way to the top. Atmospheric pressure.
B.
Are you going to guess all the letters?
B. B.
Yeah, the answer is B. From the surface of the mercury until the height of the mercury only. Okay, so this is the atmospheric pressure. Careful with this, okay, careful with this. All right. What happens to the height of H if the glass is tilted? So I mentioned this in the previous class. If let's say the glass tube kan saya kasih sengit lah, okay, will the value of H decrease, increase, or remain unchanged? Which one?
C.
C.
Okay, it will remain unchanged. What are the two situations where the H will change? Do you remember? Hanya ada dua sebab saja kenapa H boleh berubah.
Vacuum space in glass filled with gas.
Okay, there's gas in the space. Okay, so over here there's gas, then the H akan turun. What is the other situation where the H will decrease?
Carried up to a mountain.
Okay, bring up the mountain. Okay, kalau kamu angkat this one, because the atmospheric pressure is less okay, so these are the only situations so no matter how you telangkupkan this this glass tube okay, you kasih sengit lah, you kasih baring ke apa kan, okay lah, maybe baring is a bit too dramatic lah, but if let's say you kasih sengit a little bit kan, the height will still be the same. Okay, be very careful with this. All right. So this is one of the questions that I asked in the previous class. Okay, I said remember the suction, the rubber sucker. Okay, so this works around the same principle. Okay, when you press the suction pump, let's say apa itu di rumah tu kita panggil tu pelocok kah itu, yang let's say something stuck in your sink, right? Then you pump so that this one. Okay, so this basically works around the same principle. When you press the suction pump, okay, what you're actually doing is all this air inside here, you are pushing it out. Okay, you push out all the air. Okay, then when you push out all the air, inside here will become a temporary vacuum. Temporary vacuum. And because there is a vacuum over here, the surrounding atmospheric pressure, which is stronger, will push the suction pump. Okay, so the pump sticks to the wall because the atmospheric pressure is more than the pressure inside the pump. Okay, if you do your job well enough, there'll be totally no air inside here. All the air will be pushed out. Okay, and because all the air is pushed out, there is nothing to push back. Okay, so the atmospheric pressure senang-senang saja. Dia hanya wujud saja dan terus dia akan tolak ini. So this will be the answer. Okay, in the same way, everything, let's say you have the rubber sucker on your wall. Okay, macam mana ni? Kenapa kalau saya tekankan dia terus stick di sana? Okay, that works around the same principle. Same like car sticker. You know, when you press the car sticker, that's why when we put the car sticker, we always make sure that all the air, kita kasih, we don't want all this bubble. Because all the bubble of air, okay, akan menyebabkan the stickiness berkurang. Okay, you push out all the air so that antara the sticker and the glass there is no air. So atmospheric pressure will keep the sticker on the glass. Okay, so actually atmospheric pressure is very useful, really very useful. All you have to make sure is just make sure that the space between the thing that you want to stick and the wall has no air. The atmospheric pressure is your good friend. This one, oh, okay, sorry. This is the same thing, straw. Okay, so also to explain so when you drink the straw, right, okay, this one if you don't already know this is totally going to change your perception of when you drink next time Okay, so why is it that you have to suck on the straw? Kenapa itu straw yang kamu kena hisap? Okay, sebenarnya bila kamu hisap, you are not doing anything at all, Okay, the water doesn't come up because kamu hisap itu air. Sebenarnya kau bukan menghisap air itu. Okay, you are not actually sucking the water. You are sucking the air out of the straw. Okay, so this is, let's say this is your mouth Okay, triangular mouth pun boleh Okay, so let's say this is your mouth and you're sucking out all the air. Kamu menyedut semua udara di dalam straw ini keluar. Okay, so when you suck out all the air, inside this straw is going to be a temporary vacuum. Okay, tiada udara di sini. And what happens when inside the straw there's a temporary vacuum? the atmospheric pressure from the outside is going to push the water inside the straw. And that's how you can drink water from a straw. I repeat, when you are sucking on the straw, you are actually not sucking the water. You are just sucking the air out. Okay, kamu menyedot semua, all the air, so that when there's no air over here, atmospheric pressure is the one that's actually helping you to drink the water. Okay, which is why if let's say your straw, okay, if let's say there's a hole in your straw, it's very hard to drink water, because no matter how much you suck the straw, you cannot suck out all the air. Okay, so it's hard to drink water. And so because of that, even in space, let's say space, for example, right? You ask any spaceman, they say, hey, how you drink water? They will never answer, oh, we use a straw, because there's no point. There's no atmospheric pressure. Okay, there's no atmospheric pressure in space to push the water into the straw. So guys, be thankful for the atmospheric pressure around us. Because if there's no atmospheric pressure, you have to minum, using the tin and there's no straw. Okay, although people nowadays like, oh, okay, we should not use straw so much already now because like it's not environmentally friendly, blah, 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 blah. Okay, so next time you drink a water from a straw, please remember this. And thank God for atmospheric pressure. Because if there's no atmospheric pressure, you will not be able to drink your Milo Pink or your Nescafe Pink or whatever it is that you drink from a straw. Okay?